Right, okay, so today we're going to look at rearranging equations. So this is another skill that you'll have to have. Now, I'm only going to focus on the equations that we actually care about. So in the data book, engineering science data book, I'm only going to be working with the electronics equations in this instance. And we're just going to talk about how we rearrange these. And we're only going to focus on everything except voltage divider just now, right? We'll just focus on these guys. How do we rearrange these equations? So let's start off with Ohm's law, which is voltage equals current times resistance. Right, so because the laws about rearranging equations are the same no matter what equation you're talking about, right? I'm just going to put it in context. So we've got V equals IR. So if you want to know a voltage, if you want to be able to calculate a voltage, you'd have to know a current and a resistance. Alternatively, the way to think about it is, if in a question you're given a current and a resistance, well, that means you could calculate a voltage. However, this equation also gives you the ability to calculate a current if you know a voltage and a resistance, or to calculate a resistance if you know a voltage and a current. So how do you rearrange this equation? So there's two different ways that I would talk to you about how to do it. One of them is to put it into a triangle, and as long as you can remember the triangle, then you'll always be able to rearrange it. So there's three terms, and the I and the R multiply each other, and then V equals that. So if you've got that triangle, you should be able to rearrange this equation. So in order to rearrange the equation, all you do is cover up the value that you're looking for, and then write down the relationship of what's left. So if I cover up V, if I ignore V, obviously I don't know how I could do that here. Let's put a wee black square in, right, and fill it. There you go. Right, so if I cover up V, that means I've got I next to R, which means it's I times R. And that's the one that I've got there. So let's say I want to rearrange this equation for I instead. Let's say I want to work out a current. Cover up I. And what's the relationship? V over R. I'm going to go crazy here. V over R. Yay, fantastic. Or the last one, let's say I want to know what R equals. R equals, so I'm going to cover up R. And what's the relationship? V over I. V over I. So using a triangle is one way of rearranging simple equations. The only problem is you have to remember the triangle. So as long as you can remember that triangle, VIR, if you put one of those letters in the wrong place, it doesn't work. You've always got to have them populated, the triangle like that, and that lets you rearrange it. The other way to think about rearranging equations is to think about the maths of it. So if you've got V equals I times R, if you want to rearrange it for I on its own, so swap it all over, so you've got I on the left. So that's the same equation, just written down with left swapped for right. Doesn't matter if you swap left or right, that's fine. And then what I do is I could divide both sides by R, so that they two would cancel out, which leaves me with I equals V over R. So you can justify your rearranging mathematically if you want, and all you're doing is using the rules of maths, which hopefully you already know. So you can see I equals V over R, I equals V over R. And then the same works for R. So again, move them over. If you want to rearrange that so it fits the same pattern as the one before, and then divide both sides by I, they two cancel out, and that leaves you with R equals V over I. So you can see those are our three forms of Ohm's law. Yeah, that's Ohm's law rearranged. That's how to rearrange it. You can use a triangle, or you can use the kind of rules of mathematical precedence and interaction in order to rearrange it. What other equations have we got that we might have to rearrange? Resistors in series. So this is an interesting rule. So resistance in series, you know what a resistor is, and you know the units of resistance. They are ohms. Alright, so if that's 10 ohms and that's 12 ohms, because they're in series with each other, any current that goes through the 10 ohm has got to go through the 12 ohm. That means we could essentially replace them with one resistor in what we would call an equivalent circuit. The equivalent circuit to that is just a simplification. So we could draw it as one resistor. We could work out the total resistance. In this case, because they're series, the data book tells us that R series is R1 plus R2 plus however many resistances there are. You just keep adding them up. In this case, there's only two, so the total resistance would be 22 ohms. Okay. So that's how we apply that series resistance rule. What about if we ever want to rearrange it? So in this case, it's just a law about adding and subtracting, right? So hopefully you'll be able to do this one as well. So if I told you that RS equaled 55 ohms, so the equivalent circuit looked like that. And then I said, but the original circuit looked like this. And we don't know what the value for R2 is. How could we work that out? Well, we know that RS equals R1 plus R2. 55 equals 10 plus something. So hopefully you can see that something plus 10 must be 45. But how would you prove it mathematically? You move that 10 over the other side. So you could rearrange this equation. So R2 plus 10 equals 55. And move the 10 over. So just like we did with Ohm's law, where you do the opposite action. So if I is multiplying here, we divide both sides and that removes it from 1. So that's the same deal here. You do the opposite. The opposite of addition is subtraction. So if we subtract 10 from both sides, minus 10 equals 55 minus 10. Plus 10 minus 10. They two cancel out, which leaves us with R2 equals 55 minus 10, which equals 45 ohms. So I can't give you a static form of this rearranging because it could have multiple R values in there. You know, it could be 4 or 5 or 6 resistors in series. All you need to do is, you know, use your kind of knowledge of addition and subtraction to work out if the total's 55 and one of them's 10. That must mean that what's left over is 45, because 45 plus 10 equals 55. The next one's a bit harder, and we wouldn't rearrange this one. All right, you're not asked to do this at National 5, so I'll just show you how it works. Parallel resistance. So in parallel resistance, you've got multiple resistors that appear in parallel to each other. So not all of the current that goes through one goes through the other. That's the big difference. Let's stick with the same values. That's the big difference. So what did I have in my original? 10 and 12. That's the big difference between series and parallel. You've got a node there. Some current will go through the 10, some current will go through the 12, and you don't know what the balance is. Obviously the higher resistance will get a lower current. We would like to be able to do an equivalent circuit of this as well. So there is a rule for working out total resistance in parallel, and in the data book you'll see it written as 1 over RT equals 1 over R1 plus 1 over R2 or whatever. Now it seems, I'm going to call it I'm going to call it RP, right? 1 over 1 R1 plus 1 over R2 plus however many resistors there are. In this case there's only 2. So 1 over RP equals 1 over 10 plus 1 over 12. Now you can do that in a calculator. It's important that you try 1 over 10 plus brackets 1 over 12. It's important that you keep the number rounded it to a big number like that for as long as possible, right? I'm going to memory clear. I'm going to add that into my memory. So 0.183333. So that's 1 over RP equals 0.183333. Now then, I would like to work out what RP is. I don't want to know what 1 over RP is. So I want RP on its own. We could put that into a triangle, right? So you could have a triangle, because it's only 3 terms, where you've got 1 in RP, and then your answer to the fraction in here. So that would be whatever your sum was. That's just a sign that means sum. So if I want to know what RP is, then I cover it up. Remember this? Cover up, and what does it equal? 1 over whatever the sum was. So RP equals 1 over 0.183333. So in that instance, that's how we would do it with a triangle. How do you justify that mathematically? You know, all you're doing is flipping both sides over. You're just making the bottom the top and the top and the bottom. One of the things that you should kind of be comfortable with is that any number divided by 1 is that number. So I could rewrite that side as that. It doesn't make it any less true. You know, if you've got the value 2, well, that's true. 2 over 1 is 2. Okay, so that's the same here. And then all I'm doing is flipping this side upside down to give me RP over 1, which is RP. But it means I need to flip this side upside down as well. So that's how you justify mathematically getting the same result as you get in the triangle. Okay, so you just add up those fractions and then flip everything upside down. Everybody always forgets this. Loads of people add up the fractions and get that value and think that's the answer. But it's not. So we need to reciprocate that. This is taking the reciprocal of a number. So it's just 1 divided by that number. 1 divided by 0.18333333. I've put it in my calculator so I could just recall that number in my memory. On a good calculator you'll have an answer button. 5.455. RP equals 5.455. We should round that to the correct number of significant figures, which in this case is 1 significant figure, because that 10's only got 1 significant figure. So that's 5 ohms. So there's our equivalent circuit. That's our total resistance in parallel. What other equations have they got in here that you might need to rearrange? So this one, we'll ignore that one, because that's for resistances in parallel when you've only got 2. We don't need that rule. We'll just stick with this rule. We'll always use that one. And then you can see here that these 2 rules are exactly the same. So the truth is, the only rearranging that we're ever really going to have to do in electronics is Ohm's law. We will have to rearrange it to get different values. And the parallel one, where we get to a certain point with the parallel equation and we have to rearrange it from 1 over RP equals to RP equals. So they're the only 2 times we need to rearrange an equation in electronics. What I'm going to do now is just set a bunch of questions, and I'm going to put electronics in. I'm going to put electronics in for Ohm's law, because you know that if you're given a current and a resistance, you should be able to work out a voltage. If you've got 2 of any of those 3, you should be able to work out the other one. And then the same for parallel resistance and for series resistance, but there's no rearranging required. So let me put some questions together and ask you to do these questions, and this is just to express basically your math skills in the context of electronics, right? Hold on. Right, okay, so there's 8 questions. And the first 4 are all about Ohm's law. And I've just changed the wording, so I've used I instead of current in the first couple, and I've used the word current instead of I, and R instead of resistance, and so on. So you should be able to kind of, there's no trick questions in there, it's just rearranging. First 2 are calculating voltage, and then you need to work out what you're trying to calculate in the other 2. I've then got a series resistance question, a parallel, a series, and a parallel. The 2 parallel ones are identical to each other in terms of, it's just calculate the total parallel resistance. The first series one is tell me the total resistance, and the second series one, question 7, is if the total resistance is 27, what must this R4 be? Just in case you can't read any of the values, that's 16, 22 and 32. 16, 22 and 32. That's 27 obviously. 4, 9, 2, and then R4 is the unknown one. And then in this last one, all 4 values are 1 ohm. Okay, now you've got examples of how to do these questions. write them out in your jotter clearly, and then take a picture and upload it. Remember, you can do that if you're using an iPhone. You can use the PDF scanning tool in the notes to give me a PDF of it instead of a photograph. If you're using an Android, you could download a PDF scanning app, or you could type it out, but I was typing it out, make a pain in the backside, I wouldn't bother. Okay, thanks very much.